I want to welcome you to the Showcase of Innovation Challenges. I'm the NASA Chief Technologist. My name is David Miller. I want to start off today because I want to thank my Deputy Chief Technologist, Jim Adams. He couldn't be with us here today, but Jim's been leading our open innovation effort here at NASA headquarters. He's been instrumental in creating this showcase and has been foundational in guiding our team as we chart new waters at the agency to break down barriers to innovation. So we're here today because of his hard work and his leadership. As you know, over the past 7 years, NASA has changed the course of exploration, recognizing that without new innovative partnerships with industry, we're not going to be able to achieve our journey to Mars and deep space exploration. NASA is no longer using last decade's model of stovepipe NASA-only missions. We realize that we must innovate to explore, and that means NASA and industry, not NASA or industry. So through our innovative partnerships with companies like yours, we're going to create the new knowledge and capabilities needed to enable our future missions, while American industry benefits from new products and services that support our nation's new technology economy. So NASA's mission is to drive advances in science, technology, aeronautics, and space exploration so that we can advance knowledge, education, innovation, economic vitality, and better stewardship of the Earth. NASA does this through 4 mission directorates: human exploration, science, which has 4 divisions of Earth, heliophysics, planets, planetary, and astrophysics, through the Aeronautics Research Mission Directorate, and through Space Technology Mission Directorate. So I want to tell you a little bit about the Office of the Chief Technologist. The primarily serves as an advisor to the administration. But there are 6 other functions that we perform. We provide agency-level policy direction and strategy for technology portfolio. We provide leadership for policy and strategy for innovation and prizes and challenges. Through events such as this showcase, we engage with government agencies, industry, and academia. We also track and analyze technology investment across the agency. One of the tools that we use for this is TechPort. It's an online searchable database that's open to the public, and I encourage you to go take a look. The second round of technology roadmaps was completed in 2015 and now encompasses the entire agency through 15 technology areas. That's also available online, so you can download that. If you go to NASA OCT and then look for the 2015 roadmaps, you'll find that. So OCT also helps to manage NASA's technology portfolio by using the roadmaps that tell us what we could do, using the STIP, which is the Strategic Technology Investment Plan, that tells us what we should do, the budget process, naturally yearly, that tells us what we will do, and then TechPort, which helps us to see what we are doing. So while Mars is our horizon destination, there are a number of potential intermediate destinations. We need new technology to help us make these destinations achievable. Technologies such as robotics and mobility, deep space habitation, advanced spacesuits, advanced space communications, advanced propulsion, resource utilization, and human-robot systems. Where it makes sense, we should take the opportunity to develop technology that enables multiple destinations. If we develop technology that's only tuned to one destination, then we make the architecture brittle. This is an easy thing to say, but often a hard thing to do. But we need to look around at the possible destinations that we have in exploration, as well as science and aeronautics, and we need to think about where can investments have multiple customers. So I want to suggest 3 example challenges that require innovative technology to make new missions possible. I'll start with spacecraft autonomy. We need autonomy. NASA sees that we need autonomy when 3 conditions exist: changes in the environment and the impact that that environment has on our vehicles, when that cannot be predicted. When required response time is shorter than the communication to Earth's cycle time. And when no fixed plan of action can be prescribed. Basically, that's when we don't know what we're going to see when we see it, we need to be able to react and capture it and understand it. A second area is big data analytics. We're swimming in data, yet we need better ways to extract and use the information contained therein. We need this for large model data correlation and earth science, for interplanetary vehicle health maintenance, for marrying operational data with model-based system engineering, and for making better use of available communications channels. NASA's mission also has no limit in range to target. I guess there is a limit, but it's far beyond other imaging needs. This leads to the need for ever larger apertures. As you've probably seen, and probably some of your companies have been instrumental in developing, the James Webb Space Telescope, the optical telescope assembly, fully assembled, and along with the instrumentation, the optical telescope assembly has been assembled at NASA Goddard. That's 6 meters in diameter. It exceeds the launch vehicle dynamic envelope, the fairing dynamic envelope, which is an Ariane 5. So it's going to unfold on orbit through a myriad of different deployments. But as these apertures get larger and larger, we're going to be challenged to be able to unfold them. We have to think about new ways in order to deploy these systems. In fact, the payloads we launch may not be able to launch on a single vehicle. So how do we innovate in the area of autonomous in-space servicing, assembly, and manufacturing? So I'd like to take a moment to remind us that all the technology we develop serves customers. To that end, we need to think about what our customer needs tell us and work to address those.